Let's move on to the next topic, random access memory, or generally the storage inside the computer. Today we are going to focus on RAM, which is the random access memory, which is a separate module, memory module located on the motherboard. But before that, I'm just going to review the material I've covered over the past week to be able to distinguish these terms from each other. Okay, so you know that we have different types of storage inside a computer. We have some, we have cache memory, we have register, okay, we have RAM, ROM, and we have SDRAM, and for RAM we have DDR-RAM. Today we are going to just focus on this part, but to be able to distinguish the function of these two types of memory, we need to talk a little bit about the other types of memory. If you guys remember our discussion on that we had on Wednesday, we talked about cache memory. Okay, inside a CPU, we need some form of memory to be able to process instructions and data. Okay, suppose this one, take it as a central processing unit. Okay, that's this is a CPU. Okay, this CPU, one of the important elements in the CPU is the ALU. Arithmetic logic unit. It receives data and data and instructions and performs calculation. And it is also able to do logical comparison. Okay, so in order for ALU to be able to accomplish its tasks, it needs some memories. Or some form of storage to be able to handle and process those data. Let me just Control C and Control V. Okay. So ALU needs, arithmetic logic unit needs temporary storage to be able to process those information. Okay. So we have registers. Registers are temporary storage that ALU inside a CPU uses to while processing information instruction or when doing logical comparison. Register. Okay, and inside the CPU we have another type of memory, which is a kind of fast and very expensive type of memory called cache. And we have three levels of cache inside the memory. We have L1, level 2, and level 3. cache. Okay, so inside the CPU we have registers, which are the temporary storage used by ILU when processing an operation. And this cache memory holds information, instruction, and data uh, for their turn to be processed by ILU. So when processes are waiting to be processed by ILU, they must be stored inside the cache. But ILU uses register at the same time when processing information. Okay, is that clear so far? I would
Yeah,
like you to just make distinction among all these type of storage. I don't want you to confuse them. Okay, here is the cache, here is the register. These are enclosed in a central processing unit. Okay, and we have another type of memory called SRAM or a statistic RAM. Another level of another type of storage, SRAM or a statistic RAM. Okay, uh, this SRAM can hold information for a while without the need to refreshing. Okay, so these are the three type of memories or storages uh, located inside the CPU. So we can now classify them storages. First, the one inside the CPU we have cache, we have register, as well as RAM. Okay, all these three types of storages are very fast and very expensive. So in order to provide more kind of storage for the computer, we need some form of memory outside the CPU. These are located outside the CPU but still on the motherboard. We have RAM, which is divided into two groups, SD RAM and DDR RAM, double data rate RAM, synchronous dynamic RAM, and double data rate RAM. Okay, so the difference between SDRAM and SRAM is that SRAM is located inside the CPU and it is very fast and it can keep its information uh, for a while. But DRAM, which is also called DRAM, dynamic RAM, it loses its data and power very quickly. So dynamic RAM needs refreshment 1,000 times in a second, but SRAM, which is located inside the CPU, can keep its information for a long time. That's the difference between them, and that's why dynamic RAM is slower than the SRAM. Generally, all the storages or RAM or memory, whether it is register, cache, or SRAM, are much faster than their storages outside the CPU. Okay, so we have DRAM, which is divided into two categories, SDRAM and DDR-RAM, and we have another type of storage inside a computer PC called hard disk drive. Okay, so these memories are located inside the CPU. DRAM is located on the motherboard, and HDD is a separate unit outside the motherboard, and it is the slowest but with the highest capacity element inside the computer. So HDD is the least expensive one, and CPU memories are the most expensive type of memory, most expensive and also fastest type of memory. Questions so far? All right. Let's move on to the PowerPoint, the slides. Okay, so we have random access memory, as I mentioned, located on the motherboard or mainboard. It can hold data and instruction used by CPU. It is also called dynamic RAM because it needs to be refreshed multiple times. Okay, and there is another category of the memory inside the computer. We have read-only memory. Okay, read-only memory or ROM. It can keep information even when the system is off. But DRAM and other type of memory, except for hard disk drive, will lose their information when system is off. Okay, so RAM and hard disk drive can keep their information even when the system is off. Okay, so ROM is a kind of non-volatile memory, but DRAM, dynamic RAM, is a volatile memory. Volatile. This is non-volatile. It is called non-volatile. It's classified as non-volatile because it can keep its information without need to power, even when the computer is off. Okay. So in this picture, you see these memory modules. These are called DIMM modules or memory modules, and different type of RAM modules. And as I said, we have SDRAM and DDR-RAM. We will talk about these two types of RAMs in the next slides. So we have different variations of DRAM, DIMM, which is called dual inline memory module. We have small outline DIMM, which is used inside portable devices like laptops. We have micro DIMM used on sub notebooks, very small notebooks. RIMM and SIMM both are outdated. The difference among variation of RAM. The main difference is the width of data path and how they can move data from system bus to the modules. Here in this picture, okay, at the top, you see a 288-pin DDR4 memory module. It has one notch here. So these are recognized by their pin, number of pins, and also the number of notches. Here in this one, DDR4, which is the fastest type of memory or random access memory, we have 288 pins and one notch in the middle. The second type is called DDR3, which is 240 pin, and again with one notch, not located in the middle. For DDR4, this notch is almost in the middle, but it is located to the left. We have DDR2 memory, which has 240 pin, and it can support dual channel functions. We have 184 pin DDR. Again, it has one notch in the middle and 184 pin. And we have SDRAM, which is the old version of the DDR4. Compared to DDR, it is much slower. It has 168 pins, and SDRAM stands for synchronous dynamic RAM. Okay, it synchronously transmits information, but DDR4 means double data rate. For example, if SDRAM works with 130 megahertz, double DDR works with twice the speed of the spirit RAM. So the difference between SDRAM versus DDR RAM. Okay, these are both random access memories located. They can be installed on the motherboard. Okay, SDRAM, they work roughly with 130 megahertz. You guys know what megahertz means? Is the speed at which the processor or a device can handle information. 130 times 10 to power 6 hertz. Okay, but DDR doubles that rate. So the regular DDR works roughly at this speed. 130 times 2 megahertz. So the difference between the DDR and SDRAM is the width of the data unit as well as the speed of the data, the processing speed. It doubles the data rate, DDR. So the most recent version of the RAM is DDR4, which works 4 times the speed of a regular SDRAM. So dual inline memory module, it has 60-bit data path. It has independent pins on opposite side of module. Older DIMMs were asynchronous with system bus. Synchronous DRAM or SDRAM, as I said, run synchronously with system bus. Most of them have 2 notches and they use 168 pins. So with their pins and also the notches, you can distinguish these two types of memories. DIMM technologies, we have they double the data rate of a SDRAM. We have 4 versions: regular, DDR, DDR2, DDR3, and DDR4. DDR4 is the fastest type of RAM which is currently available. So the factors that affect the capacity, feature, and performance of DIMMs are number of channels they use and how much RAM is on the DIMM, speed, error checking ability, and also their buffering. So this picture shows a motherboard with 4 memory modules, DIMM modules. Memory bank. I'm gonna skip this part. These are not very important. And types of memory used in laptops. These are pretty much the same as the type of memory used for regular PCs.